Hello everyone, in this video we study about the assignment problem. So the assignment problem, the objective of the assignment problem is to find out the allocation of the number of tasks to the equal number of facilities. Let's suppose these are the tasks and these are the number of days to complete those tasks. So we assign minimum days to each task so that you can complete all the tasks in a less time or less days. We see how we solve the example, how we use the assignment problem. So there are the two types of the assignment problem. First is the balanced assignment problem and second is the unbalanced assignment problem. So balanced means when the number of tasks is equal to the number of facilities, then the assignment is called as the balanced assignment problem. So obviously in this case the cost matrix, the given matrix we say that cost matrix, and this is the square matrix, means number of tasks is equal to the number of facilities. If the number of tasks is 4, then the facilities are also 4. So this is the 4 by 4 balanced assignment problem. And unbalanced assignment problem means the number of tasks are not equal to the number of the facilities. Means suppose the task is 4, then the facility is less than 4 or greater than 4. Then we called the assignment is the unbalanced assignment problem. So first we understand the steps to solve the assignment problem. So basic 2 or 3 steps are the most important at the starting of the assignment problems. Means first step is consider the cost matrix. Then second step, find out the minimum element. Means from the first row here the 2 is the minimum. From the second row the 4 is the minimum. From the third row the 7 is the minimum, and the fourth row the 3 is minimum. So the first step, consider the cost matrix. Second step, find out the smaller element from the each row. Smallest element from each row and subtract from the respective row, and subtract from the respective row. So from the first row 2 is the smallest element, then the subtract 2 from the each element of the first row. Means 2 minus 2 0, 3 minus 2 1, 4 minus 2 2, 5 minus 2 3. So in this way find out the all smallest element from each row and subtract from the respective rows. This third step is find out the smallest element from the column, from the each column, and subtract from the respective column. So find out smallest element from each column and subtract from each respective column. These 3 steps are the common for all the assignment problems. And after the fourth step, the procedure for the making the assignment means we give for the all the tasks we assign the number of days. Means for the all tasks we assign the facilities. So this is the fourth step. After fourth steps we only assign the assignment. So I will tell you how to give it. first we start for the first 3 steps. So let's we start to solve the example. First we find out the smallest element from the each row. So first, from the first row 2 is the smallest. At the second row 4 is the smallest. Third row the 7 is the smallest, and from the fourth row 3 is the smallest. So we subtract respective smallest element from the respective rows. So first 2 minus 2 is 0, 3 minus 2 is 1, 4 minus 2 is 2, 5 minus 2 is 3. Now we move for the second row. 4 minus 4 is 0, 5 minus 4 is 1, 6 minus 4 is 2, 7 minus 4 is 3. Now the third row, 7 minus 7 is 0, 8 minus 7 is 1, 9 minus 7 is 2, 8 minus 7 is 1. Now fourth row, 3 minus 3 is 0, 5 minus 3 is 2, 8 minus 3 is 5, 4 minus 3 is 1. So this is now our the reduced cost matrix. So these are our tasks, first, second, third and fourth, and these are our dates. So now we move for the next steps, which is find out the smallest element from the each column. Now first we find out the smallest element from the rows. Now we find out the smallest element from the column. So in the first column 0 is the smallest, so we write as it is 0, 0, 0 and 0. Now the second row 1 is the smallest, so 1 minus 1 0, 0, 0, 2 minus 1 is 1. Now from the third column 2 is the smallest, so 0, 0, 0 and 3. From the fourth column 1 is smallest, so 2, 2, 2, 0, 0. So for the assignment, examine the row one by one until a row containing a single 0 element is found. Make the assignment to the single 0 by making square around it, and then the cross the other all the zeros in the corresponding row and column. Means what? Examine all these rows first. So if the rows has a single 0, then assign this 0 as an assignment and cross. Let's suppose here no any row has a single 0, then we move for the second steps, which is if the any row has no single 0, then move for the column and examine if any column has a single 0. If as, then assign this 0 as an assignment and cross the respective 0. So for this example we start from any 0 because no single row or single column has a single 0. So we start from the here. First step, assign the 0, then cross the respective zeros as a cross, means respective row and respective column. All the 0 now get the cross. So this is cross, this is cross. For here again the cross. So respective row, column and the rows, all the zeros now get crossed. Now we examine again any row or column has a single 0. If yes, then move for it, assign the 0 as assignment, and if not, then again start from any 0. So no any row, because the second row the 2 zeros are present, from the third row 3 zeros are present, but the fourth row has a single 0 because this 0 is now the cross, and cross 0 we not supposed to the assignment. So this is in the last row the single 0 is present, so we assign the 0 as assignment, and respect to row and column all the 0 get crossed. So this is 0 now crossed. Now we move for the next assignment. So we again check if any row or column has a single 0, then give the assignment for the 0, or if not then we start from any position. So in the second and third row 2 zeros are present, and for the second and third column also 2 zeros are present. So we start from any position. Let's suppose we start from this. So respective column and the row or the 0 are crossed. Now the last third row has a single 0, and we assign the 0 as a assignment. Now if each row we get a single, so after the completion of the all steps means all the zeros are either marked or cross off, there is an assignment for each row and each column, then this is the optimal solution for the assignment problem. Means we get for each row and for each column one assignment we assign for the each row and column. So this is our the optimal solution. And if any row or any column not get any assignment, then we move for the next steps. But in this example we get all rows and column has a 1 assignment. So this is the optimal solution. So how we assign for the respective task and the days. So first, second, third and fourth. These are the tasks, and for each task we assign the days. For the first task we assign the A, for the second task we assign the B, for the third task we assign C, and for the fourth task we assign D. So what is the cost of I and A? Check from the original cost matrix. So the value of first and A means our assignment are the here 2, 5, 9 and 4. We can see here we get all the assignment at the diagonal. So the values are 2, 5, 9 and 4. 2, 5, 9 and 4. So minimum days to complete all the tasks are the total of the cost of the cost matrix, which is 20, sum of the all the cost. So for completion of the 4 tasks we require minimum 20 days. I hope you all get idea how we assign the assignment for the cost matrix. We see one more example. So in this example, to solve the following assignment to minimize the total cost. Let's suppose A, B, C, D are the items, and the assigned values are the cost of the item. So the target is assign the minimum cost for each item, so we minimize the total cost. So we follow all these steps as it is. Means first find out the smallest value from each row and subtract from the respective row. Then find out the smallest value from the column and subtract from the respective column. So first for the row we find out the smallest value. So from the first row 1 is the smallest. So 1 minus 1 is 0, 4 minus 1 is 3, 6 minus 1 is 5, 3 minus 1 is 4. Now from the second row 7 is the smallest. So 9 minus 7 is 2. Then 7 minus 7 is 0, 10 minus 7 3, 9 minus 2. So 9 minus 7 is 2. Then from the third row 4 is the smallest. So 4 minus 4 is 0. 5 minus 1 is 1. 11 minus 4 is 7. Then the 3. 7 minus 4 is 3. Now from the last row 7 is the smallest. So 1, 0, 1 and here is the 2. Sorry, from the last row 5 is the smallest. So 5 minus 5 is 0. 8 minus 5 is 3. Then 7 minus 5 is 2. Not 0 here, 2. And 8 minus 5 is 3. So this is our reduced matrix. This is the ABCD. First, second, third and fourth. Now once we complete the smallest values from the rows, now we move for the column. So from each column we find out the smallest value. But in the first column 0 is the smallest and no effect when we subtract any value from the 0. So 0 minus 0 is 0. 2 minus 0 is 2. So all the values kept as it is. From the second column also 0 is the smallest. So no effect on the second column also. 1, 2. But from the third column 3 is the smallest. So we subtract from each value 3. So 5 minus 3 is 2. 3 minus 3 is 0. 7 minus 3 is 4 and this is 0. At the last column again the 0 is the smallest, so no effect on the second last column also. 4, 2, 3, 0. Now our 3 steps are complete. We find out the consider the cost matrix, then we subtract each row smallest value from the each row, and we subtract each smallest value from the each column also. This is the items and these are the cost. Now the fourth step is assign the assignment. So for the assign the assignment, first check each row if any row has a single 0. So in the first row here is the single 0. Now the second row 2 zeros are present. From the third row 1 0 are present, and the last column 2 0 are present. So start from the first column. So in first row the single 0 are present. So we assign this 0 as an assignment and cross respective zeros from each row and the column respective column. So from the column this 0 is now get crossed and no any respective row has a value 0. Now we move for the again check any row has a single 0. So second row has a 2 0 and the third row has a 2 0. So now we check for the column, any column has a single 0. So yes, if we see the second column carefully, then the second column has a only single 0. So this is our the assignment, and respect to all the zeros from the column and the row get crossed. So this is this 0 is crossed because this is the respective row for the assignment, and no any column has a 0. Now we move for the again next, any row has a single 0, no, but column has a single 0. So let's suppose for the third column we give the assign for the assignment. So respective column and row all the 0 get crossed. But now in this case the third row not and the fourth column not get any assignment. So this is not the optimal solution. For the optimal solution we want at least one assignment in each row and each column. So in this example we don't have assignment for the third row. So for that we move the next step. the next step says draw the minimum number of lines to cover all the zeros of the reduced matrix. So how we draw the line? Which row has a no assignment marked as an arrow, means in this way. For each row in which no assignment was made, mark a tick like this. Then examine the marked row. This is our marked row. If any zero element occur in the row, mark a tick to the respective column and containing those zero. Means once first step, which row has no assignment, mark as a tick. Then examine any zero present in the respective row. As here is the zero is present, then the tick for the respective column, because in the first column the zero is present, so we tick for the first column. Now the third step. Now examine the marked column. If any assigned zero element across the column, the tick the respective row containing those assigned element. So now we examine the assigned zero from the respective column. So in the first row we see the assigned zero, so tick for the respective column. I hope you get which steps we follow. First, a tick for the row which has no assignment. Now examine the row and which zero has a cross, tick for the respective column, and in the column see where the assigned zero is present and tick for the respective column. Draw the lines through each marked column and each unmarked row. So this is our marked rows. So we want draw the line for the unmarked rows. Unmarked rows and marked column. So this is the second row is unmarked row. The last row is the unmarked row and marked column, and this is our marked column. The objective to draw the line is we want to cover all the zero in the minimum line. When we perform the steps, that time always in our mind kept that in the minimum row we want to cover all these zeros. In the lines of the cost price we want to cover all the zeros. We can see here in the last row 2 zeros are present and we cover all these 2 zeros. In the second row 2 zeros are the present and again we cover in the line and the first column also. So total in 3 lines we cover all the zeros of the cost price. Once complete these steps, then examine the smallest element from the uncovered element. Means which elements are covered by line, not suppose those elements. The element which are not covered by the line, examine those uncovered elements and find out the smallest element. So 1 is the smallest element from the 3, 2, 4, 1, 4, 3. These are the uncovered elements in the matrix and 1 is the smallest. Examine the smallest element from the uncovered element and subtract from the uncovered element. So we perform one by one steps, means you get clear idea. Subtract smallest element from the uncovered element. So 3 minus 1 is 2, 2 minus 1 is 1, 4 minus 1 is 3. Then here 1 minus 1 0, 4 minus 1 is 3 and 3 minus 1 is 2. subtract from the uncovered element, add in the intersection line, means where the two lines are the intersect, means here the 2, we can see here the 2 is the point where the two lines are the intersect. So add the smallest element in the intersected element, means here 2 plus 1 is 3, and at the 3, two lines are the intersect, so 3 plus 1 is 4. And remaining, which elements are the covered by the line, write as it is. So 0, only a single line cross the element, only those elements write as it is. And if any intersection is formed, that time add the smallest element from the intersection point, and the third we know, subtract the uncovered element. So the 0 write as it is. Now the 0, 0, 2 is also right is it, because these elements are covered by a single line. Now here again 0, now 2, 0, 0, 2, 0, 0. So in these steps what we follow, to find out smallest element from the uncovered element, then first subtract the smallest element from the uncovered element, subtract it from the uncovered element, second add it in intersection point of two lines, this subtract, then second add, and third write the elements as it is which has crossed by the single line. Write element as it is which covered by single line. So these three steps we follow when we reduce the matrix. Now again remaining all the procedure is same. Once we get the second reduced matrix, then assign the assignment. So first examine each row which has a single 0. So we can see here in the first row itself has a single 0 present. So we assign the 0 as an assignment, then cross all the 0 with respect to row and column. So in a row no any 0 is present, but in column 1 0 is present and we cross them. Now we examine the second row, 2 0 are present. In the third row now 1 0 is present, because the second 0 we cross and we not assume the crossed 0, only a single 0. So in the third row a single 0 is present, so we assign as an assignment and cross all the 0 with respect to row and column. Now we move for the next row. So at the last row 2 0 are present. So once we complete all the rows, now we check for the column. But we can see here the second row now form the single 0. So we first assign those 0. So the respective zeros are the cross. Now at the last row again the single 0 is formed now, and this is our assignment. So for each row and for each column now we get the assignment. So this is our optimal solution. So from this assignment matrix we can schedule for the A, B, C, D the respective cost of first, second, for the A, the first cost is assigned, for the B, third cost is assigned, because for the B, third cost is assigned, for the C, second cost is assigned, for the C, second cost is assigned, and for the D, last fourth cost is assigned. So these assigned values we refer from the original matrix. So first A and 1. So value of A and 1 is 1. So we write here cost, which is 1. Now B and third. B and third, the value is 10. Value is 10. Now C and second. So this is C and this is second. So this is first. The first value is our here 1. Second value is 10 and third value is 5. So this is 5 and the last value is D and 4. So this is our original matrix and this is D and 4, which is 5. So total minimum cost is now 21. When we add all the costs, then we get 21. So when we assign for the item A the first cost, for the second item the third cost, for the C and D we assign the second and the fourth cost, then we get the minimum cost, which is 21. So here we complete the minimization assignment problem. Now we move for the maximization assignment problem. Means if we want to increase our profit, that time which steps we follow. So we assign the particular task for the particular facility to increase our profit. So in this way here we find out the minimum cost, how we reduce the minimum cost. Here we see in the maximization assignment problem how we increase the cost to assign the particular task for the particular facility. So let's see. So we see the steps to find out the maximization assignment problem. So first step, select the highest value from the matrix, subtract the highest value from the each element of the matrix, and then which matrix we get, this is the reduced matrix, and the next all these steps are the same as it is which we perform for the minimization assignment problem. All the steps which follow for the minimization assignment problem same as all the steps follow for the find out the maximization assignment problem. The small change is first find out the largest value from the matrix and subtract from the each element. So in this matrix the highest value is 41. So subtract 41 from the each element of the matrix. So 41 minus 32 is 9. Then 41 minus 38 is 3. 41 minus 40 is 1. Then 13 and 1. We subtract each element from the 41 because 41 is the highest value from the matrix. So quickly we write all these values, which is 1, 17, 41 minus 35 is 6 and 41 minus 39 is 4. So in this way we write all these values of the matrix. Now this is our the reduced matrix. This is the value of 1, 2, 3, 4 and 5, and these are the A, B, C, D and E. Now further all the steps are the same for the maximization and for the minimization. Means find out the minimum value from each row and subtract this value from the respective rows. So from the first row 1 is the minimum, so subtract 1 from the first row. So 8, because 9 minus 1 is 8, 3 minus 1 is 2, 1 minus 1 0, this is the 12 and 0. From the second row 1 is the smallest, so this 0, 17 minus 1 is 16, 12, 19 and 4. From the third row 0 is the smallest, so no effect on the third row, same right as it is, 11 and 4. Now the again fourth row 0 is the smallest, so 19 minus 0 is 19, so no effect of the subtraction of the 0, right as it is. Now the last row 1 is the smallest, so 12 minus 1 is 11, 7, 0, 5 and 1. So this is the further reduced matrix. D and E. Once we find out the minimum row, now we find out the minimum column. So from the first column 0 is the minimum, so the first column is as it is, 0, 19 and 11. From the second column 2 is the minimum, so here 0, 14, 12, 1 and 5. From the third row 0 is minimum, so as it is right, because no effect of the subtraction of 0. Now from the D column the 5 is the smallest, so 7, 9, 6, 0 and 0. Here the 0 is the smallest, so right as it is, 5 and 1. So this is the now further reduced matrix. So up till I hope you all get idea how we reduce the matrix. First we select the maximum value from the matrix. For the second, we subtract all the elements of the matrix from the highest value of the matrix. Then the third step means further all the steps for the maximization assignment problem is same as the minimization assignment problem. Means we select smallest element from the each row and subtract from the respective row. Then we find out the minimum column element from the column and subtract from the respective column. Now we give the assignment. So first check any row has a single 0. So yes, in the second row the single 0 is present. In the first row 3 zeros are present, so we not select that row, we select the second row. The single 0 is present, and once we assign this 0 as an assignment, then the respective all these zeros from the row and column get crossed out. So in the row respective row no 0 is present, but in the column 1 0 is present and we cross this. Now we move for the next row. Any row has a single 0? No. For the first row 3 0 are present. For the fourth row 2 zeros are present, and for the fifth row 2 0 are present. So we check for the column. Any column has a single 0? Yes. The second column has a single 0. So we assign the assignment and cross all these zeros from this respective row and column, cross. So these 2 zeros are crossed because this is the 0 present for the assignment 0 and no any 0 present in the column. Now we move for the next column. So for this C column 2 0 are present, and for the D column 2 0 are present. So we start for any position. So let's suppose we start from the this 0, then the respective zeros from the row and column get crossed, and this is the last 0 which is present the single, and we assign as a assignment. But this is we not get the optimal solution from this step, because for the third row we not get any assignment, and for this solution we want each row and each column has a assignment. So we move for the draw the lines where all these 0 covered by the lines. So steps, I hope you know. The first step to draw the line is which row has no assignment. First tick for that row. Check the respective row has any 0 is present. If yes, then the tick for the respective column. So we tick here. Then from the respective column, check any assigned 0 is present or not. So for the second row, we see one assigned 0 is present. Tick for that row. I hope you all get how we tick for the rows and column. First, tick for the row which has no assignment. Then check any 0 is present. Crossed 0. Yes, tick for the respective column. From the column, any assigned 0 is present. If yes, then tick for the respective row. So in this way, we tick for the row and column. Now our task is draw the line for the unmarked rows. Unmarked rows and marked column. Marked column. Unmarked row. So first row is unmarked. The fourth row is unmarked. And the fifth row is unmarked. Draw the lines for the unmarked row and marked column. So first row is our marked column. Objective to draw the lines is, in the lines all the zeros are covered by the lines. So we can see here all the zeros are covered by the minimum line 4. This is 1, 2nd, 3rd and 4th. From the 4th line we covered all the zeros from the matrix. Now the next step is select the smallest value from the unmarked elements. So here 14, 12, 12, 8, 9, 6, 4, 4. These 8 elements are the unmarked lines. Unmarked elements. So from these 8 elements, 4 is the smallest element. So subtract 4 from the unmarked lines. Add 4 at the intersection of the lines. And remaining all the covered elements of the lines write as it is. So these steps means first select the smallest element from the uncovered element, then subtract it from the uncovered element, add it in the intersector point of the two lines and write remaining elements as it is, in which the covered by the single line. So 14 minus 4 is 10. So here first we subtract 4 from the uncovered element. Now add 4 in the intersection point, means 8 plus 4 is 12. Now here 19 plus 4 and 11 plus 4, because these are the intersection of the two lines. So add here the smallest value. So we write here 12, 23 and 15. Now all the elements which are covered by a single line write as it is, means all. This 0, 0, 7, 0, this 0, 0 and this 1, 5, 0, 0, 0, 0 and 5, 1. These all are the elements which are covered by a single line, write as it is. So this is for the reduced matrix. Here one thing kept in your mind is, when we perform the row minimum and column minimum step, then reduce the matrix and assign the assignment. Follow these steps up till we not get the optimal solution. So when here we reduce the matrix, now we assign the assignment. So check any row has a single 0. So first row 3 zeros are present, for the second 2 zeros are present, for the third row 2 zeros are present, for the fourth row 2 zeros, and for the fifth row 2 zeros are present. Now we check for the column. Any column has a single 0. So second has 2 zeros. First has a 2 0, second has a single 0. So we start from that 0. So we assign the 0 as a assignment. Cross all the 0 with respect to row and column. So here no any 0 is present. So this is the first assignment. Now we check for the second next column. Any single 0 is present or not. So in the fifth column 2 0 are present. In fourth column 2 zeros are present, and the fifth column also 2 zeros are present. So from each row and each column has 2 0 are present. So start from any position. So let's we suppose start from the second row. So second 0 is the assignment 0. So cross all the 0 with respect to that 0 for the row and the column. So for the row here is the 0, and for the column here is the 0. Now we move for the next. Any row has a single 0. So yes, in the third row we can see here the single 0 is present, because this is the crossed 0. We not consider the crossed 0. We want only a single 0. So the respective zeros from the rows and column get crossed. Now we see any row has a single 0, no. So we move for the column. If any column has a single 0, no. For each row has 2 zeros, and for each column has a 2 zeros. Now we start from this 0, because each column and each row has a 2 zeros now. So when we assign this 0 as assignment, then cross all these zeros with respect to rows and columns, cross. Now the last one is this 0 get assigned. Now all the rows get assigned by the assignment zeros. So this is our now optimal solution. So now the assignment schedule is, for the 1 we assign B, for the second we assign A, for the 3 we assign E, for the 4 we assign C, and for the 5 we assign D. So we write now all the cost, but the cost is written from the original cost matrix. So for the 1 and B, the value we check from the original matrix, which is 38. So we write here 38. Now 2A and 3E. So 2A is 40 and 3E, which is 37. So we write here 40 and 37. Now 4C and 5D. So 4C and 5D, which is 41 and 35. 41 and 35. So the maximum cost is summation of all the value, which is 191. So in this way we find out the maximum cost also. We see one more example of maximization of assignment problem. So in this problem, a marketing manager will assign a zone Z1, Z2, Z3 and Z4 for 4 salesmen S1, S2, S3, S4. This salesman has a different for the different zone. So we find out the maximum value for the each salesman. So let's we see how we find out. So first step, as I say, first find out the maximum element from the whole cost matrix. So the maximum value is 37. Subtract 37 from each element. So 37 minus 7 is 30. So the value is 30. 37 minus 12 is 25. 37 minus 37 0. 37 minus 18 is 19. Now 37 minus 25 is 12. This 10, 19, 12, For each element we subtract from the 37. So this is 21, 34, 20, 40, 23, and 37 minus 9 is 28. So this is our reduced matrix. These are the zones Z2, Z3 and Z4, and these are the cells lines. Now the next step is find out the minimum value from each row and subtract from the respective row. So the minimum value from the first row is 0. So this is the right as it is, because any value subtract from 0 is the same. Now from the second row, 10 is the smallest. So 12 minus 10 is 2. This is 0. 19 minus 10 is 9. And 12 minus 10 is 2. Now from the third row, 14 is the smallest. So the value is 7, 20, 6 and 0. And from the last row, the 12 is the smallest. So the value is 5, 0, 21 and 60. This is the second one. Once we complete the row, now we move for the column. Find out the minimum value from each column and subtract from the respective column. So 2 is the smallest from the first column. So 30 minus 2 is 28, 0, 5, 3. From the second column, 0 is the smallest. So the second column write as it is, 20, 0. Now from the third column again, 0 is the smallest. So this is also now write as it is. And from the last column, 0 is the smallest. So no effect on the column. These are our salesmen, and these are the zones. Now once we write the reduced matrix, then we assign the assignments. So first check the any row has a single 0. Yes, for the first row itself has a single 0. Now cross all the 0 with respect to assignment element. So here first row no any 0 is present. For the column is also no any 0 is present for the cross. Now we move for the second row. 2 zeros are present. For the third row, 1 0 is present. So we now assign the 0. Now cross the all the zeros with respect to that 0. So no any 0 is present. Now we move for the next. So for the last row also only single 0 is present. So we assign that 0 as assignment. Cross all the 0 with respect to that row and column. Now again this is the our assigned 0, because here again a single 0 is present, because this is the cross and we not consider crossed 0. We only want a 0. So here for each 4 row we get the 4 assignments. So no here need to draw the lines. So we can say that the schedule is S1 has Z3 zone, S2 has Z1 zone, S3 has Z4 zone, and S4 has Z2 zone. And the values are S1 and Z3. Write the values from the original matrix. So Z1 and Z3 is 37, 37, Z2 and Z1, S3 and Z4. So these are the values which we schedule for the salesman and the zone. So we write here 37, 25, 23 and 25. So the maximum cells are cells is equal to summation of all the cost, which is 110. So I hope all you get the idea about how we find out the minimum or the maximum values for the given cost matrix. We find out all the minimum or the maximum assigned problem for the balanced matrix, because every matrix has a n by n matrix. Now the next unbalanced assignment problem we see in the next video. I hope you get all the idea about the balanced assignment problems regarding the minimization and the maximization. The next all these methods of unbalanced assignment problem. Next three types of the assignment problem we see in the next video. So now for that we stop here. I hope you all get the knowledge about the assignment problem. Thank you.